Okay, here are solutions to page 2 of the practice with half-life and isotopes. So you watched an instructional video explaining page 1, and then page 2 you were supposed to do on your own. So in a different color, okay, in a different color, I want you to make corrections to your work. So if you have not done this yet, turn off this video and do this on your own. Only watch this video when you are making corrections to work that you have already done, please. Thank you. So, different color, meaning if you wrote in pencil, you can now write in pen, or blue to black ink, or whatever. It doesn't necessarily have to be in red, but I want you to, for example, if you got something wrong, do that and write in the correct answer if that's the case. Okay, so again, we're finding neutrons, protons, electrons, valence electrons. Carbon has an atomic number of 6, so 6 protons, equal number of electrons, an atomic mass of 12, meaning 6 neutrons, and 4 valence electrons, all the way down. This would be carbon 15. Notice how protons plus neutrons equals 15. Notice how lithium and potassium both have 1 valence electron. They are in the alkali metals, the farthest left column. And then for these, so this is potassium, and then K plus and K minus. These would be ions of potassium. The positive charge means it has lost an electron. Notice how the total number of electrons decreased by 1. And K minus means it has gained an electron. Notice how the number of electrons went from 19 to 20. And then for the valence electrons, for the K plus, it lost that 1 electron, meaning it now has a full octet, a full shell of valence electrons, like the noble gases. And likewise with K minus, when it gains an electron, it goes from 1 to 2 valence electrons. Next up would be Na25, sodium 25. Notice how the number of protons plus neutrons equals 25. That's the atomic mass of this isotope. Fluorine is a halogen. It has 7 valence electrons, total of 9, etc. And then xenon, some people are struggling with this. It has 54 protons, and so you look at the atomic mass, it says 131.29, so I did 131 minus 54, giving 77 neutrons. Okay. So again, correct your work in a different color, please. Number 7 for half-life. So there's definitely some confusion about this. Notice how we're told the half-life of, what are we talking about, vitamin C here is 5 hours. And these aren't equal 5-hour increments. Okay, actually here they are, but whatever. So I've created this little table here where we have the starting value of 180, and each half-life I divide by 2. 180 divided by 2, 90. 90 divided by 2, 45. 45 divided by 2, 22.5. 22.5 divided by 2, 11.25. 11.25 divided by 2, etc., etc. So, this jumps from 0 to 15 hours. Alright? In 0 to 15 hours, 3 half-lives have elapsed or passed, meaning from 180 to 90, that's 1 half-life, that's another half-life, and that is another half-life. So we would have 22.5 milligrams. At 20 hours, half of that, 11.25 milligrams. And at 25 hours, 5.625 milligrams. Okay, so beware, this is where the common mistake is going to happen. That was 3 half-lives right there. Okay. 1, 2, 3. In our next question, we have 10 milligrams, and so 10 goes to 5, to 2.5, 1.25, and 0.625, dividing by 2 every time. 1 half-life, 2 half-life, 3 half-life, 4 half-lives. So after 5 hours, looks like we have 5 milligrams. After 10 hours, we have 2.5 milligrams. And after 15 hours, we have 0.625 milligrams. So, as you are correcting, do this in a different color. If by chance you got everything correct, I just want to see that you are doing this. Check, 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 check. Okay, in a different color. If you have not made corrections to your page 2, you will get 0 points for it. Thank you.